Yeah, hi. I'm assuming I'm live. Okay. Okay. It's wonderful to be here with you. And Jahan and Akash, thank you so much for making this happen. So my name's Amir Hussain, and I'm founder and CEO of Spark Cognition, which is an artificial intelligence company based in Austin, Texas. I do have a number of interests, and at the moment, in addition to running Spark Cognition, I'm also on the board of the computer science department at UT Austin, which is the number 6 computer science department in the world, and possibly higher in AI. We've just launched a new machine learning institute there, which our goal is to make it the number 1 in the world. I also have served on the Global Security Task Force for the Center for a New American Security, which is a very prominent DC think tank. And then I'm also a member of the Council on Foreign Relations. In particular, under Admiral McRaven, a small group of us put together recommendations as part of the Global Security Task Force. And then I also serve on the board of NATO IAB, which is an organization that's looking at applications of artificial intelligence, particularly for surface and undersea warfare. And also my book, The Sentient Machine, is essentially an exposition of what artificial intelligence is already doing in the world and what it might be able to do in future, and in particular addresses some of the concerns that a lot of people have. AI will take all the jobs. AI will create monsters that run amok and put us at risk. And so there's a perhaps you'll find it interesting, but in my view, an interesting argument in the book that walks us through all of that and really asks fundamental questions about what indeed is our purpose as human beings. The book is widely available on Amazon and everywhere else. There's about 7 or 8 different localized versions that have been printed in various countries, so in case you're interested. Now, the first thing that I'm going to talk about is you might have heard this expression, software eats the world. It came from Mark Andreessen, who was the founder of Netscape and now a very prominent venture capitalist in Silicon Valley. The question is, how does software eat the world? How does the physical act of consuming something occur with software? So on the left, you have a traditional gas engine. And as you can see, there are a lot of components. There's a timing belt, there's pistons, there's a carburetor, there's a whole variety of valves, complexity. On the right-hand side, you see an electric motor, and this hardly has any of that complexity. Now, all of the functions of a gas engine, for example, when you accelerate, you're opening up the throttle, there's more fuel flowing in, the air-fuel mixture is adjusted, the engine produces more power, there's a higher rate of spin on the axle. Then you brake, that's a separate mechanism. All of these mechanical constructs belong to the old world. If you think about how electric motors do this with much fewer, with significantly fewer parts and diminished complexity, they add software as that layer that makes up for all of these parts that you see on the left. So literally, the carburetor goes away because now it's just an electrical signal being delivered, running off of some sort of an embedded computer and being delivered directly to the motor. Braking is a function that partly the motor is able to do itself. So literally, the addition of software onto simple mechanical constructs like an electric motor can cause the legacy system to no longer be useful. And so now think about all the companies that specialize in the internal combustion engine. Think about all of the people that make a living doing this. What happens to them? This is clearly a shift in technology that's taking place. But that sort of appeals to, let's say, mechanical engineers, maybe blue-collar workers working in factories and so on. But what about, creative knowledge workers? Surely knowledge workers are beyond reproach, right? Their work will always be done by them, and machines can't be smart enough to take their jobs over. Well, on the left here, you see a human typing furiously fast and cranking out a lot of source code and writing a program. And that's the old way of doing coding. On the right hand, you see an algorithm within a simulated environment developing the code in order to make robots of various different constructions walk without any explicit instructions, without any explicit understanding really of physics or Newtonian mechanics. The evolutionary approach here allows you to come up with the code that in days past, developers would have spent long hours trying to come up with. And it's not just about the savings of time, it's also the flexibility that you get with the evolutionary approach, because now you can evolve different software for different creatures. You can evolve different software to deal with different conditions. Here, the issue is of balance. You have one of these robots that's learned how to walk being assaulted with blocks. And at some point it tumbles, but the reality is that its ability to deal with all of this has not been programmed in by a human being. It's been learned. So there are numerous ways now in which artificial intelligence can be used to build artificial intelligence, right? And there's this cyclicality, this positive cyclicality that started to come about. Now, at the heart of a lot of this is a current revolution in deep networks, deep learning. And what is deep learning? To make it very, very simple, it's neural networks which have been around for a while. They've been around for decades, but just stacked in ways that make the structure very deep. So they're able to take in a lot of inputs and then perform all sorts of computations in multiple layers. The connectivity can vary based on the type of network. And then at the end, you get an answer. And the algorithm that goes through training a neural network, in other words, configuring all the connections and the weights in just the optimal way to provide the correct answer, that algorithm is called backpropagation. So the deep learning revolution is powered by big computers, lots of memory, lots of data that can be thrown at ever larger networks in ever deeper layers, and this backpropagation algorithm that can train all of these networks. But the one thing to remember about neural networks, it's a kind of a magical result, which is that neural networks, and I'm going to put an asterisk here and come back and explain the asterisk, but neural networks can do anything. You can teach a neural network any computable function to an arbitrary degree of precision, given enough data. If you had enough data, this neural network structure can learn anything. Now, in practicality, do you have enough data? Do you encounter other training issues and problems? Do you have enough compute? Is the problem the kind of problem that can be translated to, what a neural network does? Those are complexities. But at the same time, this result is magical because the neural network is a universal problem solver. And that is at the heart of this new revolution in artificial intelligence. I'll be quick to tell you that this isn't the only thing that's exciting. Deep learning, while everybody talks about it, isn't the only exciting thing. There's lots of related fields, for example, reinforcement learning, which also leverages deep learning. There's explainability in these neural networks. There's one-shot learning, where with a small amount of data, you can learn much like a human child does. But even beyond all of these, there's also a growing focus on other techniques. For example, techniques that marry symbolic AI with connectionist AI, with these types of neural approaches. But most interesting to me is if neural networks are universal problem solvers, how can we build technology that, again, is AI that builds AI in turn? How can we automate the construction of these neural networks? And so at Spark Cognition, we've done a lot of research in neuroevolutionary approaches, neuroevolutionary, evolving the neural structure of these networks without explicitly coding them. Go back to that video of the developer hacking away versus a genetic algorithm teaching a robot how to walk. We are building algorithms that use the power of genetics to build entire brains. And what you see here are simulations of our Darwin software using a large number of GPUs to evaluate different neural models and then to be able to determine how well or not so well they're doing. If they don't do so well, they get discarded. The best of a generation then contribute to the next generation, their seed. So this Darwin platform has been revolutionary and can solve a large number of problems, design neural structures that you, me, other experts wouldn't have thought of, because that's not how human beings think. Okay, so software is eating the world, and you can see how that physically is changing. Neural networks are at the heart of this revolution, and we've now built technology that can automate the construction of neural networks. So how will all of these things come together to change the world? Well, Spark Cognition launched a 50-50 joint venture with our partner Boeing, which, as you know, is the world's largest aviation company. And we created a subsidiary called SkyGrid, where SkyGrid is applying all of our artificial intelligence capabilities to build safer skies. The future of the world is not thousands of airliners in the sky, all piloted by human beings. It's actually millions of aircraft, autonomous, of all shapes and sizes, fulfilling missions that you and I haven't even yet imagined. That's what the future of the skies looks like. And now, as Cisco was to the internet, as routers were to the internet, there is a technology needed to manage three-dimensional space and even beyond our atmosphere. And that precisely is what SkyGrid is. We've just launched our first product. If you go to the SkyGrid website, you will see in the US now it's integrated with the FAA. So, for example, you can connect directly with a drone through the SkyGrid application. It uses AI algorithms. You can simply, with your finger, designate where you want the drone to fly. It creates optimal routing. If you have more than one drone, we have enterprise versions that do that as well. Automatically, your flight plan is checked against a huge list of criteria. Are there advisories in the area? Are there no terms? What about the weather? What about the micro weather? All of that is factored in by the AI. And then a flight plan is constructed completely autonomously. That's submitted to the FAA. And if that comes through, then you can go ahead and fly. All the while you're flying, the system is being monitored with respect to all the other assets that are in the sky. There's all sorts of deconfliction capabilities and a very sophisticated mechanism to keep skies safe at scale. There's even machine vision integration now with that. So there's a ton of capability that artificial intelligence brings in building a new world where the skies look different. The skies are organized, safe. Millions of aircraft can integrate with them, but without disrupting, our daily lives. And that's work that we're doing. Another thing that we're doing is bringing AI to power, the power industry. A couple of years ago in South Africa, there were some power failures at significant power plants. And when there was a post-mortem done of that event, it turned out that part of the reason why that occurred was because the staff that was manning those power stations wasn't appropriately trained. And so a lack of training in these areas, in these jurisdictions, can cause significant damage to the economy. Large power plants go down. So we started thinking, how do we embed artificial intelligence in the power plant? Our Spark Predict system is already watching in oil and gas, the largest rigs in the world. It's finding downtime events that no other system has been able to find. Earlier this year in March, we detected an event which would have caused $10 million of downtime in a single instance. So we know that this is all within the art of the possible. So how do you apply this to power? And so we did apply our capabilities to turbines, each one of which can cost nearly $100 million per turbine. They're basically very large jet engines. And we've delivered amazing results. We've found conditions that would have led to failure of catastrophic varieties just purely through AI. And now where we are is we're incorporating in a very specific way the ability for the AI to also learn the physics, not just look at the data. That does great, and it allows us to protect a large number of assets, but to also incorporate learning from physics and become much smarter. And that's sort of the future here. The vision for Spark Cognition, of course, has always been we want to embed AI in the physical systems that run the world. Success for us is being embedded in the power plants, in the water plants, protecting cyber operational technology assets all over the world, in the military services, in rockets, everywhere where artificial intelligence can integrate data at rapid scale, build models, protect assets, optimize the asset, make things better, safer, faster, cleaner, even in an environmental context. That's the business that we're in. I'll give you one more example. We were hit by the pandemic, still in the throes of it, and I hope we can shake it off here with this vaccine that's coming up. But Spark Cognition has a research team that's run by one of the foremost practitioners of AI in the world, Professor Bruce Porter, who is the two-time chairman of UT Austin Computer Science. And our CTO is also the former CTO of IBM Watson. So we've got a terrific team, and we applied our capabilities to 6 areas where we developed prototypes. We actually supplied some of this capability to local healthcare, investing in forecasting with our Darwin system, using neuroevolution to forecast, to interpret radiological scans, all sorts of data, the sound of a cough, etc. These are all things in the art of the possible. With our SkyGrid system, next-gen logistics, you might have certain areas that you can't easily reach, or sending people there might be harmful because the rate of infection is too high. SkyGrid can now track COVID in addition to all the other layers of data. And with drones, it's possible to ship supplies to some of these areas. Similarly, contact tracing. We actually prototyped a peer-to-peer device with no tie-in to a person's identity. And earlier you were hearing about the blockchain. In a similar way, completely distributed, trustless system to allow people to do contact tracing and still not feel like they're being tracked on their phones everywhere. We developed the world's first ventilator. This design that you see here was built from scratch at Spark Cognition. The first ventilator that was built from the ground up with predictive maintenance in mind. Because with artificial intelligence, one thing that you get is you can put an engineer in the box, right? So we can put an engineer inside this ventilator. It's an AI engineer. We can put the mind of that engineer in this box. And now when you have to have tens of thousands of these ventilator fleets all over the world, how do you maintain them? Well, one way to maintain them is to embed artificial intelligence in those systems. Drone deliveries, of course, both with Boeing as well as many of our other partners. There's a lot of work going on in particularly medical drone deliveries. And then finally, via swarms of drones, using a variety of different sensors in open spaces, automatic monitoring of health protocols, both in terms of IR readings that might be an indication of, for example, someone being ill, as well as generally ensuring that groups of people are implementing social distancing. So we've implemented, tested various of these. They're in different phases of completion. In addition to this, of course, we've done a lot with folding at home, contributing a lot of compute capacity to help discover a cure. And then also with our prototyping capabilities, developing a lot of PPE equipment and distributing that here within the United States. So that, in a nutshell, is, to me, how artificial intelligence changes the world. It changes the world physically, right? It's a science. It's not just a tool or a technology. It's a way of thinking. And when you start thinking that way, you find opportunities to replace the physical with the virtual. And then when that virtual component becomes intelligent, you realize that you've given something life, and you've given something the ability to optimize at a distributed level that never existed since the beginning of time. That leads to a different world in power, in defense, in cybersecurity, in agriculture, in everywhere, manufacturing. And if you are interested in these topics, which I've sort of spent my life thinking about these topics and working towards them, I can offer you a couple of links here, as well as two of my books, The Sentient Machine and Hyperwar, both of which are available online. So thank you very much. And of course, I would be delighted to answer any questions that you might have.
So let me just begin with the first question. So there's been a lot of cyber attacks on large organizations in Pakistan. So given the advances in AI, do you think it's going to be increasingly hard for companies to keep their systems secure?
Yeah, I think the sophistication of these attacks will continue to increase. And actually, artificial intelligence systems are also being used to automatically generate new types of attacks. So the cyber war will very quickly morph into an AI cyber war. These attacks are also, when they're serious, they're not just targeting a laptop, they're also targeting physical infrastructure. And I think a lot of work needs to be done to develop a risk profile, and to truly understand the attack surface that we are dealing with in any country, and then work to plug those gaps, because there are now very high-profile examples of successful large-scale cyber attacks that have taken down physical infrastructure. In a country like Pakistan, that could be catastrophic, and it's certainly an area of opportunity for entrepreneurs locally, and also an area that the government, I think, should pay attention to.
Okay, thank you for that. There's another question over here, and talking about locally, talking about Pakistan. Do you see credible use cases in Pakistan of today, like in the situation we are in right now?
I do. I think in agriculture, there's a lot that can be done. The application of drones, I think, is tremendous. And that doesn't work without AI. So I mentioned to you SkyGrid. If you check that out, it's a joint venture with Boeing. It's all about that, basically being able to take drones, deploy them at scale, arm them with sensors, detect disease, be able to take out very selectively pockets of disease in a crop, for example, doing surveys, keeping cities secure, virtual policing at much lower cost. Medical applications, huge range of applications. So the question is not, are there applications? The question really is, why aren't we doing them? And I think that's really my favorite point to always bring up. It can be done. Somebody's just got to get up and start doing it.
Obviously means that emerging economies stand a chance.
When there's life, there's hope. Emerging economies stand a chance. All of us stand a chance. We need to apply ourselves. We have a lot of God-given gifts. We have a lot of skills that we develop as we go on. Emerging economies, of course, they have a chance. There's an ebb and flow in the history of nations, and the reality is you've got to keep trying. You've got to keep trying in a very realistic sort of a way, and prioritize. So I think tremendous things can come out of the Pakistani ecosystem if done right. There's no question about that in my mind.
Thank you so much, Mr. Amir Hussain. Thank you so much for your time and for shedding light upon this. Thank you so much.
My pleasure. Thank you very much.